Hi everyone, welcome to the Lyceric Papers. Today I wanted to talk about the comparison between the muon measurements that have been done out in the field and the calculation of the muon decay using the general relativity theory. So to start off with, I'm going to show you a couple of these field measurements, and you can then see the underlying results. And basically, I'm just going to jump ahead a little bit here. You typically see at sea level about 1/3 of the counts that you see at around 4,000 meters. And as you can see here at 4,000 meters, they have about a count of 6 muons per second, and at sea level, they have an account of about 2. Now, having said that, at a square meter, the thumb rule is about 160 to 170 counts per square meter. So basically with this, you could then say 2 is about 160, and then the 4,000 would be about 500 muons per square meter. So going to the field test, you can see also the same factor of 3 and they basically seem to have used the same kind of a scintillator, because it also has 2 and 6. And then here they use some different one. This is a hot air balloon, also done around Texas, same latitude. So you can see here also a factor of 3 between sea level and the altitude of around 12,000 foot, which is close to 4,000 meters. Then we have another measurement that was done in several different locations, typical in the southern part of the U.S. Here, everything okay except for that one measurement in Mount Hamilton. So, yeah, to be expected, every once in a while you do see 1 or 2 measurements that don't fit, which I'm okay with, because this is a typical effective measurement. But in general, you can see that there's a consistency that between 4,000 and sea level, you see a factor of 3. The next point is that everyone kind of more or less says when you look at the energy of these muons at sea level, you're talking roughly around 4 giga-electronic volts. So I'll leave the text here for everyone to look at, but fundamentally I've added here what it means, how to calculate this, and there's actually hyperphysics has a pretty good explanation on how to calculate the muon count depending on the speed of the muons and the decay rate. Interesting, they also use the 4 giga-electronic volts, and there they come up with the gamma of 38.8. And so basically using the same math as described here in hyperphysics, I put these numbers in a Excel sheet. Basically, what I was doing is I used the numbers, like, the 500 at 4,000 meters, and then basically put in the factor C, which gives me a gamma rate of 5.7. And as you can see, from there to sea level, I always roughly hit about the 160 to 170 counts, which means that this C of about 0.9847 of the speed of light gives you that gamma rate of 5.7. So the black eye, or the egg on your face, is actually when you then do the calculation for the energy of the muon at sea level, and lo and behold, you only reach basically 0.6 gigaelectronic volts. That's a little bit of disturbing because, like the hyperphysics said, if you use the 4 gigaelectronic volts, then your gamma rate gets close to 40, and basically the measurement results of the muon count would not fit at all. So here's a strong contradiction. So the Einstein calculation does pretty good for the muon counts, but it doesn't jive with the actual energy levels. So I did a classical example, and I said basically I can get the same gamma rate by saying that that particle is 5.6, 5.7 times the speed of light. And of course, it'll then produce the exact same results as the gamma of 5.7 or 5.6. Interestingly, though, then using the classical physics, I also achieve the right energy level. So that's kind of an interesting result that I'd like to share here, that I don't know how to interpret this, but and just for everyone's second thought, I actually used a factor of root 2 for the speed, because I also added the de Broglie wave function of these muons to be exactly correct. And that's why I'm getting, the 3.4, 3.5 gigaelectronic volts. And that's pretty close to the 4, average gigaelectronics volts that all the people that have measured the energy levels get as an average. So that's pretty close. At least, like I said, I'm a factor of 6 times closer than on the energy side than the relativity theory using the classical physics. So that pretty much comes to an end, and I just wanted to show this, and hopefully I get some thoughts and some lively conversation as to where this contradiction comes from. Having said that, thank you for watching, and I'm looking forward to see your comments. Thank you very much. Bye-bye.